Welcome to the Bedtime Lab, where we embark on wondrous journeys through the universe, exploring the mysteries of the cosmos as we gently drift into the realm of dreams. Tonight we're diving into the fascinating world of supernovae and stellar explosions. So, sit back, relax, and let your imagination wander among the stars. Did you know that a supernova is one of the most powerful events in the universe? It's the explosion of a star, and it can outshine entire galaxies for a short period of time. Imagine a single star shining brighter than billions of others combined. Isn't that a spectacular thought? Speaking of brilliance, a supernova can release as much energy as the sun will emit over its entire lifetime. That's energy equivalent to what our sun will produce over 10 billion years, unleashed in just a few weeks. It's staggering to think about such immense power being released in such a short span of time. Now, let me share something interesting. The word supernova comes from the Latin words for super, meaning above or beyond, and nova, meaning new. It was believed to be a new star appearing in the sky. However, it's more like the grand finale of a star's life. Can you imagine witnessing such a cosmic event? Here's a fascinating fact. Not all stars end their lives in a supernova. Only stars with a mass about 8 times greater than our sun are destined for such a dramatic end. Smaller stars, like our sun, fade away more gently, becoming beautiful planetary nebulas surrounded by glowing gas. It's like the universe has its own way of painting masterpieces in the sky. Speaking of endings, when a massive star explodes as a supernova, it can leave behind a neutron star or, in some cases, a black hole. Neutron stars are incredibly dense. Just a sugar cube-sized amount of neutron star material would weigh as much as a mountain on Earth. It's almost unimaginable, isn't it? And here's something truly mind-bending. Sometimes a supernova leaves behind a pulsar, which is a type of neutron star that emits beams of radiation that sweep across space like a cosmic lighthouse. These pulsars can spin incredibly fast, with some rotating hundreds of times per second. It's as though they dance in the universe at dizzying speeds. Did you know that supernovae play a crucial role in the cosmos by spreading elements throughout the universe? The iron in your blood and the calcium in your bones were forged in the heart of stars and scattered across the galaxy by these powerful explosions. In a way, we all carry a piece of the stars within us. Speaking of elements, supernovae are responsible for creating many of the elements found on Earth. Elements heavier than iron, such as gold and uranium, are formed during these stellar explosions. So, when you hold a piece of jewelry made from gold, you're holding a relic of a supernova that occurred billions of years ago. Here's another intriguing tidbit. The light from a supernova can take hundreds or even thousands of years to reach Earth. When astronomers observe a supernova, they're actually witnessing an event that occurred long ago, offering us a glimpse into the history of the universe. And speaking of history, the first recorded observation of a supernova was by Chinese astronomers in 1054 AD. It was visible in the daytime for several weeks. Imagine looking up at the sky and seeing a new brilliant star appear out of nowhere. What a sight that must have been. Did you know that the remnants of a supernova can create a beautiful display called a supernova remnant? These remnants are the glowing debris of the exploded star, forming intricate patterns and shapes that are truly mesmerizing to behold. It's as if the universe is leaving behind a cosmic artwork for us to admire. Here's a curious fact. The Crab Nebula is one of the most well-known supernova remnants, and it was created by a supernova that exploded in the year 1054 AD. The pulsar at its center spins about 30 times per second, illuminating the nebula with its energetic beams. It's a living testament to the power and beauty of supernovae. Speaking of beauty, supernovae can produce incredibly bright bursts of gamma rays, known as gamma ray bursts, which are the most energetic explosions observed in the universe. These bursts can release more energy in a few seconds than our sun will produce over its entire lifetime. It's mind-boggling to consider such colossal forces at play in our universe. Now, let me share one last fascinating tidbit for tonight. Some scientists believe that a supernova explosion could have played a role in the extinction of certain species on Earth. The radiation from a nearby supernova could have affected Earth's atmosphere and climate, demonstrating just how interconnected we are with the cosmos. And there you have it, a gentle journey through the dazzling world of supernova and stellar explosions. I hope these wondrous facts have kindled a sense of awe and wonder as you prepare to drift into a peaceful slumber. Feel free to share where you're tuning in from in the comments. It's always delightful to know where our fellow stargazers are enjoying the magic of the universe. Until next time, sweet dreams, dear friend. Let me paint another picture for you about these cosmic marvels. Imagine a star that's nearing the end of its life, burning brightly in a spectacular finale before fading away. But did you know, some supernovae can outshine entire galaxies for a brief moment. It's like lighting a match in a dark room and suddenly overwhelming all the dim lights around it. This brilliant flash can last for several weeks, and during this time, it can be seen from millions of light years away. Here's something to ponder. The energy emitted by a single supernova can be so intense that it outshines the combined light of all the stars in its host galaxy. This is not an everyday occurrence, and happens just a few times per century in a galaxy like ours. It makes you wonder about the sheer power that these explosions hold. Speaking of power, let me tell you about hypernovae. These are even more energetic than the typical supernova, releasing 10 to 100 times more energy. Hypernovae are thought to be associated with the birth of black holes, a mysterious and captivating aspect of our universe. This staggering release of energy is still a subject of fascination and research among scientists today. And here's a curious thought. The most massive stars, those over 25 times the size of our Sun, may not even leave behind a visible explosion. Instead, they might collapse directly into a black hole, a silent but significant event in the universe. The idea of such a colossal transformation happening without a visible trace is truly intriguing. Now, have you ever wondered how star systems are affected by supernovae? When a star goes supernova, the shockwave can trigger the formation of new stars. It's a cycle of life and death on a cosmic scale. The shockwaves compress clouds of gas and dust, sparking the birth of new stars and planets. It's like a cosmic gardener planting seeds for the next generation of celestial bodies to grow. And here's a delightful twist. The colors we see in supernovae remnants aren't just for show. They reveal the elements present in the exploded star. For example, green hues may indicate the presence of oxygen, while red might be a sign of hydrogen. It's as if the universe has a color-coded message just waiting for us to decode. Speaking of decoding, did you know that supernova remnants can emit radio waves? These radio waves travel across the cosmos and can be detected by astronomers on Earth, providing insights into the composition and properties of the remnants. It's like listening to a cosmic symphony, with each note telling a story of the universe's past. Here's something that might surprise you. Not all supernovae occur at the end of a star's life. Type supernovae are a different kind of cosmic event, occurring in binary star systems. In these systems, a white dwarf star accumulates material from its companion star until it reaches a critical mass and explodes. This type of supernova is used as a standard candle by astronomers to measure distances in the universe, helping us map the cosmos. Speaking of maps, imagine a supernova so powerful that it could be seen with the naked eye from Earth. Such was the case with SN 1987A, a supernova observed in the Large Magellanic Cloud in 1987. This event provided astronomers a rare opportunity to study the life cycle of a supernova in great detail. Now, let's ponder the role of supernovae in the galaxy's chemical evolution. These explosions disperse elements throughout the universe, enriching the interstellar medium with the building blocks for planets and life. It's an ongoing process, ensuring that the next generation of stars and planets have the materials they need to form and thrive. Here's a fascinating tidbit. The study of supernovae has even helped refine our understanding of dark energy, the mysterious force driving the accelerated expansion of the universe. By observing distant supernovae, astronomers have gathered critical data that supports the existence of this enigmatic force reshaping our universe. And did you know that supernovae also have a role in galactic recycling? They contribute to the dynamic ecosystem of galaxies by driving winds that transport gas and dust, facilitating star formation in other regions. It's like a cosmic recycling program, ensuring that nothing goes to waste. Let me share a historical gem with you. The Tycho supernova, observed by Tycho Brahe in 1572, was a turning point in our understanding of the heavens. It challenged the prevailing belief that the stars were unchanging, showing that the universe is far more dynamic than previously thought. Lastly, consider this. There is a type of supernova known as a disguised supernova, which occurs in the crowded cores of galaxies. These supernovae are often obscured by dust and gas, making them difficult to detect. Yet they still play a crucial role in the life cycle of galaxies, even if we can't always see their dramatic finale. I hope these insights have sparked a sense of wonder and curiosity about the universe's grand performances and the role these stellar explosions play in the cosmic theater. The universe is a place of endless fascination, and there's always more to explore and ponder as you journey into the realm of dreams. Did you know that supernovae come in different flavors? In addition to the well-known Type R and Type 2, there are also types IB and ICE. These types are distinguished by the presence or absence of certain elements in their spectra. It's like having a cosmic menu, with each supernova type revealing a different recipe of stellar ingredients. Here's an intriguing detail. Type IB and IC supernovae are believed to originate from massive stars that have lost their outer hydrogen layers, either through winds or interactions with a companion star. This loss of layers gives them a unique signature when they explode, offering astronomers clues about the life history of the star. Speaking of life histories, did you know that some stars can undergo repeated partial explosions? These are known as pulsational pair instability supernovae. The star expels parts of its outer layers over time, and these ejections can eventually lead to a final, complete explosion. It's like a star releasing waves of energy before its grand finale. Now, consider this. The remnants of a supernova can form a neutron star, or, in some cases, a pulsar. A neutron star is incredibly dense, with a sugar cube-sized amount weighing about as much as all of humanity. When such a star spins rapidly, it becomes a pulsar, emitting beams of radiation that sweep across the cosmos like a lighthouse, signaling its presence. Here's something rather touching. The Crab Nebula, a famous supernova remnant, is home to a pulsar that rotates 30 times per second. This pulsar acts like a cosmic clock, keeping time with astonishing regularity. Imagine a star's heart still beating in the vastness of space long after its fiery demise. Have you ever wondered how supernovae are named? They're given designations based on the year they were discovered, followed by a letter or letters. The first supernova of the year gets the letter A, the second B, and so on. So, a name like SN2023Z tells you it was the 26th confirmed supernova in the year 2023. Speaking of names, there was a supernova once known as Supernova of the Century, SN1993J, discovered in the galaxy M81. It was the brightest supernova visible with a telescope in the northern hemisphere at the time. This extraordinary event helped astronomers better understand the late stages of stellar evolution for massive stars. If you're curious about the speed of supernova shockwaves, here's a captivating fact. These shockwaves can travel at speeds of 10,000 kilometers per second. Imagine the raw power required to propel material at such an incredible velocity. It's a testament to the immense forces at work during these cosmic events. And here's a peculiar notion. Some supernovae can produce gamma-ray bursts, which are among the most powerful explosions in the universe. These bursts release as much energy in a few seconds as the Sun will emit over its entire 10 billion-year lifespan. It's almost beyond comprehension, the magnitude of such events. Have you ever heard of a kilonova? These are even rarer than supernovae and occur when two neutron stars or a neutron star and a black hole merge. The collision produces heavy elements like gold and platinum and releases a spectacular burst of light. Imagine entire galaxies enriched with these precious metals, courtesy of such cosmic collisions. Here's something truly remarkable. The gravitational waves from merging neutron stars were first detected in 2017, a groundbreaking discovery that opened a new window into the universe. These ripples in space-time confirmed theories and provided insights into the behavior of matter under extreme conditions. Speaking of extreme conditions, have you ever wondered about the temperatures during a supernova? At the heart of the explosion, temperatures can soar to billions of degrees Celsius. It's a fiery furnace where new elements are forged, reshaping the cosmic landscape. Did you know that supernovae can also produce cosmic rays? These high-energy particles travel through space and can eventually reach Earth, where they contribute to the natural background radiation. They're like tiny messengers from distant stars, whispering tales of their explosive origins. And here's a gentle reminder of our cosmic connections. The calcium in your bones and the iron in your blood were forged in the heart of a star, scattered across the universe by supernova explosions. It's a humbling thought that we carry a piece of the cosmos within us. Finally, consider the poetic beauty of light echoes. When a supernova explodes, its light can reflect off surrounding dust clouds, creating a delayed echo of the event. This phenomenon allows astronomers to study the explosion long after the initial burst of light has faded, enabling them to peer into the past with clarity. As you drift into dreams, let these notions of stellar explosions and cosmic wonders fill your thoughts with awe. The universe is a vast, intricate tapestry, woven with threads of light and energy, and every supernova is a brilliant testament to the endless cycle of creation and change. Imagine the universe as a grand stage where stars perform their final acts before taking a bow. In this cosmic theater, supernovae often leave behind fascinating remnants. One such remnant is known as a supernova remnant bubble. These bubbles are vast, spherical shells of gas and dust, expanding outward from the explosion. They're like delicate cosmic balloons, silently growing larger over thousands of years. Did you know that some supernovae can be so powerful that they briefly outshine their entire host galaxy? This immense burst of light can be visible across vast cosmic distances, offering a fleeting glimpse of the star's swan song to observers light years away. Imagine standing on a distant world, gazing up at the night sky as a single point of light eclipses the collective glow of billions of stars. Here's an interesting thought. Supernovae are essential to the universe's chemical evolution. Without them, many of the elements necessary for life as we know it would not exist. The remnants of these stellar explosions seed the cosmos with elements like carbon, oxygen, and nitrogen, which eventually find their way into new stars, planets, and even living organisms. It's like nature's way of recycling on a cosmic scale, ensuring that nothing goes to waste. Speaking of the elements, did you know that supernovae play a crucial role in the creation of heavy elements like uranium and thorium? These elements can only be formed in the extreme conditions present during a supernova explosion. The next time you glance at a piece of jewelry or hold a tool in your hand, consider that its origins might trace back to one of these ancient cosmic events. Here's a delightful surprise. Not all stellar explosions result in a supernova. Some stars end their lives in quieter, less explosive ways. For example, a white dwarf star can slowly cool and fade away over billions of years, becoming a black dwarf, a cold and dark remnant of its former self. This silent end contrasts sharply with the fiery spectacle of a supernova. Can you imagine a supernova happening in real time? There are actually dedicated teams of astronomers who monitor the skies every night, hoping to catch sight of a new supernova as it occurs. With today's technology, they can detect even the faintest signals of a star's final moments. It's like being a cosmic detective, piecing together the story of a star's life from its final explosive chapter. Here's a notion that might intrigue you. Supernovae can occur in binary star systems, where two stars orbit each other closely. In some cases, one star can siphon material from its companion, eventually triggering a supernova explosion. This celestial dance between two stars can lead to dramatic outcomes, with one star ending in a brilliant explosion while the other is left to drift alone in the aftermath. Have you ever wondered just how far-reaching the effects of a supernova can be? When one occurs, the shock wave can affect nearby star-forming regions, compressing gas and dust and triggering the formation of new stars. It's a beautiful cycle, where the death of one star can lead to the birth of many others, perpetuating the cosmic dance of creation and destruction. Here's a fact that might surprise you. The energy released in a supernova is so immense that it can momentarily overpower the gravitational pull of a black hole. This can lead to an event known as a hypernova, which is one of the most energetic explosions in the universe. Such events are rare and extraordinary, pushing the boundaries of our understanding of physics and energy. Now, let's delve into the realm of art. The vibrant colors seen in images of supernova remnants are not just for show. These colors represent different elements and their interactions with light. For instance, red might indicate hydrogen, while green could signify sulfur. It's as if the universe itself is painting with a palette of elements. creating stunning visual masterpieces for us to admire. Consider this. The study of supernovae has helped astronomers refine our understanding of the universe's expansion. By observing distant supernovae, scientists have been able to measure how fast the universe is expanding and confirm the existence of dark energy, a mysterious force driving this expansion. It's a cosmic puzzle that continues to challenge and inspire astronomers worldwide. In a curious twist, some supernovae do not fit the standard classifications and are known as peculiar supernovae. These oddballs challenge our understanding of stellar explosions and hint at the complexity and diversity of processes at play in the universe. They remind us that there is still so much to learn about the cosmos, keeping the spirit of discovery alive. Here's a gentle reminder of our shared cosmic heritage. Every time you gaze at the stars or ponder the mysteries of the universe, remember that we are all part of this grand, interconnected tapestry. The stars' fiery ends are not just distant events, they are integral chapters in the story of our existence. Let these thoughts of wonder and awe accompany you as you drift into a peaceful slumber, surrounded by the infinite beauty of the cosmos. Let me share something you might find intriguing. Supernovae can create cosmic rays, high-energy particles that travel through space at nearly the speed of light. These rays can travel vast distances, even reaching our own planet and influencing the Earth's atmosphere. It's fascinating to think that events happening light years away can have ripple effects that touch our daily lives here on Earth. Imagine these particles as messengers from the universe, whispering the stories of distant explosions. Speaking of influences, did you know that supernovae have played a role in shaping the structure of galaxies? When a massive star detonates, the blast can send shockwaves through the surrounding gas and dust. This can create regions of turbulence and pressure that can eventually give rise to new stars and even the spiral arms of galaxies. It's like watching a cosmic symphony unfold, where supernovae are the dramatic crescendos driving change and evolution on a grand scale. Here's a thought-provoking detail. The light from a supernova can take millions of years to reach us, meaning when we observe one, we're actually looking back in time. This time-traveling light offers a window into the past, showing us how the universe looked millions of years ago. It's an awe-inspiring reminder of the vast scales of time and space that define the cosmos. Now, consider this. Not all supernovae emit visible light. Some can produce bursts of neutrinos, ghostly particles that rarely interact with matter. These neutrinos can pass through entire planets without leaving a trace, making them incredibly elusive. Yet, when detected, they provide invaluable information about the core processes occurring during a supernova, offering clues that light alone cannot reveal. Shifting to a more human-centered perspective, the study of supernovae has profound implications for understanding the origins of life. These stellar explosions distribute essential elements like iron and calcium throughout the universe, elements that are fundamental to the formation of planets and ultimately life itself. It's humbling to think that the calcium in your bones or the iron in your blood was forged in the heart of a long-destroyed star, connecting us to the cosmos in a deeply personal way. Have you ever pondered how powerful a supernova truly is? The energy released in just 1 second during a supernova can surpass the total energy output of our Sun over its entire 10 billion-year lifespan. This staggering energy release exemplifies the sheer might of these cosmic events, capable of reshaping entire regions of the galaxy and altering the fates of countless stars and planets. Here's something else to marvel at. While supernovae are rare in our own galaxy, Occurring only a few times per century, they are happening constantly across the universe. In fact, it's estimated that a supernova occurs somewhere in the observable universe every second. This constant cycle of birth and death is a testament to the dynamic and ever-changing nature of the cosmos, a never-ending ballet of creation and destruction. On a more technical note, the study of supernovae has led to significant advancements in our understanding of nuclear physics. Supernovae provide natural laboratories where extreme conditions of temperature and pressure allow scientists to test theories about nuclear reactions and the behavior of matter. These insights help refine our models of stellar evolution and nuclear processes, deepening our comprehension of the universe's workings. In a captivating twist, some supernovae can lead to the formation of neutron stars, incredibly dense remnants left behind after the explosion. A neutron star packs the mass of our Sun into a sphere only a few kilometers across, creating gravitational fields so strong that they can warp space-time itself. These enigmatic objects are celestial wonders, offering a glimpse into the limits of matter under extreme conditions. Let your imagination wander for a moment. In some cases, the gravitational collapse during a supernova can result in the birth of a black hole. These mysterious entities possess gravitational forces so intense that not even light can escape their grasp. The formation of a black hole is like the universe drawing the final curtain on a star's life, a poignant end to a story written in starlight. Consider the role of supernovae in cosmic chemistry as well. Elements like nickel and cobalt, vital for various technological and biological processes, are synthesized in the fiery cauldrons of supernova. These elements then become part of the interstellar medium, contributing to the chemical diversity necessary for the development of complex systems and life as we know it. Reflecting on the cultural impact of supernovae, ancient civilizations often recorded these brilliant celestial events without understanding their true nature. Supernovae were seen as omens or signs from the heavens, inspiring myths and legends across different cultures. It's fascinating to consider how these distant explosions have shaped human history, influencing art, religion, and science through the ages. Finally, let's ponder the future. As our technology advances, we are developing the capability to observe supernovae in unprecedented detail, potentially predicting them before they occur. This foresight offers the possibility of witnessing these cosmic events up close, unveiling their secrets and further enriching our understanding of the universe. With each new discovery, we inch closer to unraveling the mysteries of these stellar titans, deepening our connection to the cosmos and our place within it. May these thoughts of stellar wonderment and the grand narratives of the universe guide you gently into the realm of dreams, where the stories of stars continue to unfold in the tapestry of your imagination. Imagine the wonder of a supernova triggering a cascade of events that forever transforms the universe. One such event is the production of cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles have the power to alter the chemistry of planets they encounter, potentially influencing the conditions for life. Isn't it fascinating to think that cosmic rays from distant stars might have played a role in shaping the atmospheres of planets, including our own? Speaking of cosmic influences, did you know that supernovae can even affect the rate of star formation in galaxies? When a supernova occurs, it can compress nearby clouds of gas and dust, triggering the birth of new stars. This means that explosions from the death of one star can lead to the creation of new generations, a beautiful cycle of destruction and renewal that echoes across the cosmos. Here's another intriguing aspect. Supernovae can be classified into different types based on their characteristics and the elements they produce. The most common are Type 1 and Type 2 supernovae. Type 1 supernovae often originate from white dwarfs in binary systems, while Type 2 supernovae result from the collapse of massive stars. Each type offers unique insights into the life cycle of stars and the processes that govern our universe. Have you ever wondered how bright a supernova can get? A particularly luminous one can outshine an entire galaxy, emitting more light than billions of stars combined. This incredible brightness makes it possible for astronomers to study these events from vast distances, allowing us to peer deeper into the universe than ever before. It's like the cosmos is lighting a beacon, inviting us to explore its mysteries. Now, let's delve into the concept of failed supernovae. In some cases, a massive star might undergo a collapse without the explosive fireworks typical of a supernova. Instead of a brilliant explosion, the star may quietly implode into a black hole. These silent cataclysms are harder to detect, but they remind us of the varied and unpredictable nature of stellar deaths. Interestingly, supernovae also play a role in creating magnetars, a type of neutron star with an incredibly strong magnetic field. These objects are among the most magnetic entities in the universe, with fields 1 trillion times stronger than Earth's. The study of magnetars helps us understand extreme physics and the conditions that lead to their formation. Did you realize that supernovae can influence the very shape of galaxies? The energy and shock waves from these explosions can sculpt the interstellar medium, leading to the formation of spiral arms and other galactic structures. This means that the grand design of galaxies is, in part, shaped by the death throes of ancient stars. On a more human scale, supernovae have inspired countless works of art and literature throughout history. From Vincent van Gogh's Starry Night to modern science fiction, these celestial phenomena capture our imagination and fuel our creativity. They serve as a reminder of our deep connection to the universe and the wonders it holds. Let's consider for a moment the role of supernovae in calibrating cosmic distances. By observing the brightness of certain types of supernovae, astronomers can measure the distances to faraway galaxies. This technique, known as the standard candle method, helps to map the expansion of the universe and refine our understanding of cosmology. Can you imagine a supernova leaving behind a nebula, a stunning visual spectacle that continues to glow for thousands of years? The Crab Nebula is a famous example, a remnant of a supernova observed by Chinese astronomers in the year 1054. These cosmic artworks are testament to the enduring legacy of stellar explosions, offering a glimpse of the beauty that follows destruction. Another captivating fact is the connection between supernovae and gamma-ray bursts. These bursts are some of the most energetic events in the universe, releasing more energy in seconds than our Sun will over its entire lifespan. Scientists believe that some gamma-ray bursts are linked to supernovae, providing new insights into the most violent phenomena in the cosmos. As we ponder these explosive events, it's worth noting that supernovae enrich the interstellar medium with heavy elements. These elements are essential for planet formation and the development of complex life. Without supernovae, the universe would lack the diverse chemistry necessary for life as we know it, underscoring their vital role in cosmic evolution. Let me share something truly awe-inspiring. The shock waves from supernovae can travel through space for thousands of years, continuing to affect nearby stars and systems long after the initial explosion. These waves can redistribute matter and energy, playing a crucial role in galactic ecology and the ongoing processes of star formation. Finally, imagine the potential for future supernovae to be visible from Earth. Betelgeuse, a red supergiant star located around 640 light-years away, is a candidate for a future supernova. Should it explode, it could become as bright as a full moon, a rare spectacle that could last for weeks and be visible even in daylight. Such an event would be a once-in-a-lifetime opportunity to witness the power and beauty of a stellar explosion up close, sparking wonder and curiosity across the globe. May these thoughts of stellar spectacles and their profound impacts on our universe guide you gently into a realm of dreams filled with cosmic wonders. As you drift off, imagine the stories yet to be discovered in the heavens above, each one a testament to the incredible dance of life and death unfolding in the universe. As we continue to journey through the cosmos, let's explore some lesser-known aspects of supernovae and stellar explosions. Did you know that supernovae can be a catalyst for cosmic rays? These high-energy particles travel across the universe at nearly the speed of light, and they can even impact Earth by contributing to the natural background radiation we experience every day. It's fascinating to think how an event so distant can still have an effect on our planet. Another intriguing fact is the role of supernovae in creating exotic isotopes. When a star explodes, it forges new elements and isotopes, many of which are not found naturally on Earth. These radioactive isotopes, such as iron-60, can eventually find their way into our solar system and even become embedded in geological formations on Earth. Scientists study these isotopes to learn more about our galaxy's history and the frequency of supernovae near our solar system. Speaking of distant impacts, did you realize that supernovae might have influenced the trajectory of life on Earth? Some researchers suggest that past supernovae could have affected the climate, even contributing to mass extinction events by altering the atmosphere. It's a humbling thought that the life and death of stars can play such a pivotal role in shaping the history of life on our planet. Here's something to ponder. The energy released in a supernova can be so immense that it briefly outpaces the sun's energy output by billions of times. In fact, during the peak of a supernova's brightness, it can emit more energy in a single moment than the sun will produce over its entire 10 billion-year lifetime. This staggering release of energy is what makes supernovae such powerful forces in the universe. In the realm of the extraordinary, consider that supernovae can lead to the creation of cosmic dust. This seemingly mundane substance is actually a fundamental component in the formation of stars and planets. The dust from ancient supernovae can coalesce over millions of years, eventually forming the building blocks of new solar systems. It's remarkable how something as simple as dust can hold the secrets to the universe's ongoing creation. Let's take a moment to appreciate the role of supernovae in the balance of the universe. Without these explosions, the cosmos would be a much different place, lacking the heavy elements necessary for planets and, ultimately, life. Supernovae ensure that elements like carbon, oxygen, and iron are dispersed throughout the galaxy, contributing to a diverse and dynamic universe. And here's a thought-provoking tidbit. Some supernovae are believed to be the result of a merger between two white dwarfs. These binary systems can spiral into each other, eventually igniting a thermonuclear explosion. This type of supernova, known as a type Ia, is particularly important in measuring cosmic distances and understanding the expansion of the universe. Speaking of distances, did you know that supernova can be used to trace the movement of galaxies? As galaxies move through space, they carry the remnants of past supernovae with them. By studying these remnants, astronomers can learn about a galaxy's history and how it has interacted with its environment. It's like following a cosmic breadcrumb trail, revealing the stories of galaxies across time and space. Another fascinating aspect to consider is the possibility of supernova triggering new star formation. The shock waves from a supernova can compress nearby gas clouds, initiating the process of starbirth. This means that the death of one star can lead to the birth of many others, a beautiful cycle of rebirth that perpetuates the life of the universe. Imagine, too, the diverse types of supernovae that exist beyond our own galaxy. Different galaxies can host unique stellar populations, leading to supernovae with varying characteristics. By studying these differences, scientists gain insights into the diverse processes and histories of galaxies, enriching our understanding of the universe's vast complexity. And here's a fascinating notion. Supernovae might play a role in the distribution of cosmic magnetism. The intense magnetic fields generated during these explosions can propagate through space, influencing the magnetic environment of galaxies. This adds another layer of intrigue to the already complex interactions between cosmic phenomena. Let's not forget about the impact of supernovae on nebulae, those ethereal clouds of gas and dust. When a supernova occurs within a nebula, it can illuminate the surrounding material, creating a stunning cosmic light show. The resulting interplay between light and matter can last for thousands of years, providing a breathtaking visual record of the universe's ongoing transformations. As we reflect on these cosmic wonders, it's worth noting the potential for future discoveries about supernovae. New technologies and observatories continue to push the boundaries of what we know, opening up new avenues of exploration and understanding. With every new supernova observed, we inch closer to unraveling the mysteries of the universe. In this gentle exploration of the astounding world of supernovae, may you find inspiration and wonder guiding you into a restful night. As you sleep, let your dreams be filled with the shimmering lights of distant stars, each one a testament to the beauty and power of the cosmos. In the quietude of the night, let's meander further into the awe-inspiring realm of supernovae. Here's an intriguing thought. Some of the stardust that forms during these cosmic explosions might eventually wind up in the atmosphere of faraway planets, possibly even those that harbor life. This means the very elements essential for life as we know it could have traveled across the galaxy, a cosmic journey lasting millions of years. Can you imagine the atoms that make up our bodies tracing their origins back to such a spectacular event? Speaking of journeys, did you know that the light from a supernova can travel for millions of years before reaching us? The glow we observe in the night sky is a time capsule, a glimpse into an ancient past where the universe was a very different place. It's a reminder that the cosmos is a vast and interconnected tapestry woven across time and space. Let's delve into the heart of the explosion itself. The core of a star undergoing a supernova collapse is so dense that a sugar cube-sized amount of this material would weigh as much as a mountain here on Earth. This immense density creates the perfect conditions for the birth of either a neutron star or, if the remaining mass is substantial enough, a black hole. The idea that these stellar remnants can transform into such exotic objects is nothing short of extraordinary. And here's another captivating detail. During a supernova, neutrinos, which are nearly massless particles, are released in a colossal burst. These neutrinos carry away a significant portion of the energy released in the explosion. Remarkably, these elusive particles can pass through entire planets without being stopped, silently threading the universe with their ghostly presence. Shifting our gaze from the particles to the grand scale of things, consider the light echo phenomenon. As the light from a supernova spreads outwards, it can illuminate dust clouds located light years away, creating a cosmic ripple effect. This allows astronomers to observe the supernova's light long after the initial explosion has dimmed. Did you ever wonder about the role of supernovae in the cosmic chemical factory? These explosions are responsible for creating half of the heavy elements in the universe. Before a star explodes, it undergoes a series of nuclear fusion reactions, producing elements like silicon, sulfur, calcium, and iron. The explosion then scatters these elements through space, seeding future generations of stars and planets. Consider this: the Crab Nebula, a well-known remnant of a supernova observed by Chinese astronomers in the year 1054, continues to expand at a speed of about 1,500 kilometers per second. This nebula is not only a visual spectacle, but also a laboratory for studying the physics of supernovae and the evolution of their remnants over centuries. Here's something to stir your imagination. Some supernovae, known as hypernovae, are much more powerful than typical ones. These events are believed to be associated with the formation of gamma-ray bursts, which are the most energetic events known to occur in the universe. The intense radiation from a gamma-ray burst could potentially affect the atmospheres of planets in nearby systems, showcasing the far-reaching consequences of these mighty explosions. As we continue to explore, consider the role of supernovae in galactic ecology. These explosions can trigger waves of star formation in their host galaxies, acting as cosmic gardeners that cultivate new life from the chaos of destruction. The shock waves generated by the explosion compress nearby molecular clouds, sparking the birth of new stars and perpetuating the cycle of cosmic renewal. On a more philosophical note, imagine that every supernova we observe today tells the story of a star that lived and died millions of years ago. The light we see is a message from the past, a testament to the universe's enduring legacy and the interconnectedness of all things. As you ponder these celestial marvels, let's turn our attention to the concept of supernova imposters. These are events that mimic the brightness of a true supernova, but are instead caused by different processes, such as the dramatic outburst of a massive star shedding its outer layers. These imposters remind us of the complexity and diversity of stellar life cycles, each one offering a unique glimpse into the workings of the cosmos. And wouldn't you be intrigued to learn that supernovae can create exotic forms of matter? In the aftermath of a supernova, conditions become so extreme that it's possible for quark matter, a state where quarks are freed from their typical confinement within protons and neutrons, to form. This exotic matter adds another layer of mystery to the already enigmatic nature of these stellar explosions. Finally, let's reflect on the interconnectedness of all these phenomena. Every supernova, in its brilliant and violent demise, contributes to the universe's ongoing story, a narrative that spans billions of years and countless light years. As you drift into sleep, let these cosmic wonders fill your thoughts, providing a soothing reminder of the vast and beautiful universe that surrounds us. Let me share something intriguing with you. The energy released by a single supernova can outshine an entire galaxy, albeit briefly. Imagine the energy output of billions of stars being matched by just one dying star. It's a dazzling testament to the raw power locked within these celestial giants. Speaking of stars, did you know that not all supernovae are born from massive stars? Some are the result of a binary system where a white dwarf accumulates matter from a companion star until it reaches a critical mass and explodes. This type is known as a Type 1 supernova, and it plays a crucial role in measuring cosmic distances. And here's something fascinating about these cosmic beacons. Supernovae are so bright that they can be observed across vast distances, allowing astronomers to study galaxies far beyond our own. This visibility helps scientists explore the universe's expansion, providing a clearer picture of its past and future. But supernovae are not just beacons, they are also timekeepers. By analyzing the light from certain supernovae, astronomers can determine the age of distant galaxies, piecing together the timeline of cosmic history. Consider this: the remnants of supernovae, such as the famous Cassiopeia A, continue to teach us about the universe long after the initial explosion. Despite occurring over 300 years ago, Cassiopeia A is still revealing secrets about the life cycles of stars and the physics of high-energy environments. And did you ever wonder about the role played by supernovae in the formation of cosmic structures? The shock waves from these explosions can help shape the interstellar medium, influencing the formation of new stars and even the spiral arms of galaxies. Here's a curious fact. Sometimes, the light from a supernova is magnified by the gravity of a massive object, such as a galaxy cluster that lies between the supernova and Earth. This phenomenon, known as gravitational lensing, can create multiple images of the same explosion, providing a unique opportunity to study its properties in detail. And speaking of detailed studies, have you heard about the role of supernova remnants in cosmic ray production? These remnants are believed to be one of the primary sources of cosmic rays, which are high-energy particles that travel through the galaxy at nearly the speed of light. Another remarkable aspect of supernovae is their ability to produce intense magnetic fields. The rapid rotation and collapse of a star's core can amplify magnetic fields to incredibly high strengths, influencing the behavior of charged particles and potentially affecting the surrounding interstellar space. And let's not forget the peculiar phenomenon of radio emissions from supernovae. As the shock wave expands and encounters the surrounding material, it produces radio waves that can be detected by telescopes, offering insights into the explosion's dynamics. Did you know that studying supernovae can also inform us about dark energy? Type 1a supernovae are used as standard candles to measure the universe's expansion, providing crucial data that led to the discovery of dark energy, a mysterious force driving the acceleration of this expansion. This connection between supernovae and one of the universe's greatest mysteries is a reminder of how interconnected everything is. And have you ever considered the role of supernovae in the formation of planetary systems? The elements forged in these stellar furnaces are crucial for the formation of planets. Without supernovae, the universe would lack the diversity of elements needed to create rocky planets and, ultimately, the conditions for life as we know it. This cosmic recycling process underscores the intricate dance of creation and destruction that governs our universe. Speaking of cosmic cycles, let me tell you about the supernovae-driven winds that can regulate star formation in galaxies. These powerful winds, generated by the energy of multiple supernovae, can blow gas out of galaxies, affecting the rate at which new stars can form. In this way, supernovae act as both creators and regulators within their galactic environments. It's also fascinating to think about the potential role of supernovae in triggering mass extinctions on Earth. Some scientists speculate that nearby supernovae could have significant impacts on our planet's climate and biological history by depleting the ozone layer or altering atmospheric chemistry. While this remains a topic of debate, it highlights the profound influence these distant explosions can have on our home planet. Finally, Let's touch upon the unpredictable nature of these explosions. While astronomers have identified many potential progenitor stars, predicting exactly when a supernova will occur remains a challenge. This unpredictability adds an element of mystery and wonder to the study of supernovae, reminding us that the universe is full of surprises waiting to be uncovered. As you drift further into relaxation, let the mysteries of supernovae fill your thoughts, serving as a gentle reminder of the boundless wonders that exist beyond our everyday experience. And here's something you might find surprising. The aftermath of a supernova can lead to the birth of exotic cosmic objects called neutron stars. Imagine a single teaspoon of material from a neutron star weighing as much as a mountain. This incredible density results from the core of a massive star collapsing under its own gravity, squeezing protons and electrons together to form neutrons. This process creates an object so compact that its gravity can warp the very fabric of space-time. Speaking of neutron stars, did you know that some of them become pulsars? Pulsars are fascinating objects that emit beams of radiation from their magnetic poles, appearing to pulse as they rotate. This regular pulsing helps astronomers map the galaxy and even test the general theory of relativity. The precision of these cosmic timekeepers is truly remarkable, often rivaling the best atomic clocks we have on Earth. Here's another captivating fact. Not all stellar explosions end in the creation of neutron stars. Some massive stars leave behind black holes, regions of space where gravity is so strong that not even light can escape. The transition from a supernova to a black hole is one of the most dramatic transformations in the cosmos, illustrating the delicate balance between mass and gravity in dictating a star's fate. And did I mention that supernovae can also lead to the formation of planetary nebulae? These colorful clouds of gas and dust are the remnants of a star's outer layers, gently illuminated by the remaining core. The intricate shapes and vibrant colors of these nebulae are both a visual delight and a testament to the complex processes of stellar evolution. They remind us of the transient beauty inherent in the life cycles of stars. Speaking of beauty, the light from a supernova can be so intense that it forms unique chemical compounds known as supernova molecules. These molecules, which include unusual isotopes of elements, are not found anywhere else in the universe. Their presence in the cosmos adds a layer of complexity to our understanding of chemistry and the potential for new forms of matter. Here's something else intriguing. Supernovae can create shock waves that travel through space at incredible speeds. These shock waves compress interstellar clouds, triggering the formation of new stars. This chain reaction of star birth and death highlights the interconnectedness of all things in the universe, a cosmic dance of creation and destruction that has been ongoing for billions of years. Speaking of cosmic dances, have you ever considered the role of supernovae in shaping the Milky Way galaxy? These stellar explosions can help redistribute heavy elements throughout the galaxy, enriching future generations of stars and planets. By spreading elements like carbon, oxygen, and iron, supernovae contribute to the galactic ecology, ensuring that the building blocks of life are widely available. And here's a thought-provoking idea. Some supernovae are so powerful that they can briefly outshine their entire host galaxy. Known as hypernovae, these incredibly energetic explosions release vast amounts of energy, far exceeding that of typical supernovae. The sheer scale of these events challenges our understanding of stellar physics and the limits of energy production in the universe. Did you know that supernovae can also influence the magnetic fields of galaxies? The intense energy from these explosions can compress and twist magnetic fields, adding to the complexity of galactic structure. Understanding these interactions is key to unraveling the mysteries of how galaxies form and evolve over billions of years. Speaking of evolution, have you heard about the potential of supernovae to influence life beyond Earth? Some scientists speculate that the radiation from nearby supernovae could affect the atmospheres of exoplanets, potentially impacting the development and sustainability of life. This idea opens up intriguing possibilities for understanding the delicate balance required for life to thrive in the universe. And here's a curious fact. Supernovae can be linked to gamma-ray bursts, some of the most energetic events in the universe. These bursts release more energy in a few seconds than the Sun will emit over its entire lifetime. The connection between supernovae and gamma-ray bursts is a subject of intense study, as it could reveal new insights into the most extreme environments in the cosmos. Have you ever wondered about the role of supernovae in the cosmic web? The energy from these explosions can influence the large-scale structure of the universe, helping to shape the distribution of galaxies and dark matter. This interconnectedness underscores the idea that even seemingly isolated events can have far-reaching effects on the universe's overall architecture. And speaking of architecture, did you know that supernovae can even influence the formation of solar systems? The shockwaves from these explosions can compress nearby clouds of gas and dust, leading to the formation of new stars and planets. This process highlights the role of supernovae as cosmic architects, shaping the environments in which new stars and potentially habitable worlds can emerge. Finally, let's ponder the mystery of why some stars explode as supernovae, while others do not. The complexities of stellar evolution, including mass, composition, and rotation, all play a role in determining a star's fate. This ongoing puzzle reminds us of the intricate and often unpredictable nature of the universe, inviting us to continue exploring and seeking answers to the cosmic questions that surround us. As you let these thoughts gently guide you into slumber, reflect on the wonders of the cosmos and the endless mysteries waiting to be uncovered. Imagine a universe where the detonation of a star sends ripples through space, an awe-inspiring spectacle of energy and light. Let me share with you an intriguing fact. Some supernovae are responsible for cosmic rays, high-energy particles that travel vast distances across the universe. These particles zip through space at nearly the speed of light, sometimes even passing through you as you listen to this. Isn't it astonishing to think that remnants of these stellar explosions could have already journeyed through your body, connecting you to the cosmos in an invisible way? Speaking of cosmic connections, did you know that supernovae are crucial in the production of gold and other heavy elements? The extreme conditions during a supernova explosion allow for the creation of elements heavier than iron, like gold and platinum. So the jewelry you wear and the metals we use in everyday life may very well have originated in the heart of a star that exploded billions of years ago. It's a humbling thought, connecting the vastness of space to the tangible world around us. Here's an intriguing twist. Not all supernovae are caused by massive stars reaching the end of their life cycles. Some occur in binary star systems, where two stars orbit each other. In these systems, a white dwarf can accumulate material from its companion star. When it reaches a critical mass, it ignites in a thermonuclear explosion, becoming a type of supernova known as a Type 1a. This type of explosion is remarkably consistent in brightness, which makes it an essential tool for measuring cosmic distances and studying the expansion of the universe. Have you ever pondered how supernovae can be so luminous? These explosions can release more energy in a few seconds than our Sun will emit over its entire lifetime. This incredible burst of energy can shine as brightly as a billion suns, It's no wonder that supernovae were often recorded by ancient astronomers as mysterious new stars appearing in the night sky, captivating early stargazers with their sudden brilliance. Let me take you on another thought journey. The shock waves from supernovae do more than create new stars. They can also trigger the formation of cosmic filaments, vast structures that span across millions of light years. These filaments act as the scaffolding of the universe, guiding the distribution of galaxies and dark matter into a vast web-like structure. It's a beautiful reminder of the interconnectedness of all things, where even the most violent events contribute to the grand design of the cosmos. Speaking of design, have you ever wondered how supernovae were first discovered? The earliest recorded supernova observation dates back to 1154 AD, noted by Chinese astronomers. They observed a guest star that lingered in the sky for several weeks before fading away. These historical accounts provide valuable insights into the frequency and nature of these cosmic events, serving as a bridge between ancient knowledge and modern science. And here's something that might surprise you. Supernovae can be seen in other galaxies millions of light years away. The study of these distant supernovae has helped scientists refine the cosmic distance scale and improve our understanding of the universe's expansion. It's remarkable how the light from these faraway explosions can travel such immense distances, bringing us glimpses of the universe's past. Did you know that the aftermath of a supernova can sometimes be more captivating than the explosion itself? As the ejected material expands into space, it forms a supernova remnant, a colorful nebula that slowly disperses over thousands of years. These remnants, like the famous Crab Nebula, are studied extensively to learn about the life cycles of stars and the complex processes that occur during a supernova explosion. Here's a thought-provoking fact. Not all supernovae are explosive. Some massive stars undergo a quiet collapse, forming a black hole without a dramatic explosion. These failed supernovae challenge our understanding of stellar death, revealing that there is still much to learn about the final stages of massive stars. And have you ever considered how supernovae can influence the future of galaxies? By ejecting material into the interstellar medium, these explosions can enrich the galaxy with heavy elements, setting the stage for future generations of stars and planets. This cycle of enrichment and renewal is a fundamental aspect of the universe's evolution, ensuring the continuity of cosmic life. Let's delve into another fascinating aspect. Supernovae can produce neutrinos, elusive particles that pass through ordinary matter almost undetected. During a supernova, a flood of neutrinos is released, providing valuable clues about the core collapse process. Detecting these neutrinos on Earth has offered unique insights into the inner workings of stars at the end of their life, bridging the gap between theory and observation. Did you know that supernovae can have a profound impact on nearby star systems? The intense radiation and shock waves can strip away planetary atmospheres, affecting the habitability of any planets in the vicinity. This interplay between supernovae and planetary systems highlights the delicate balance that life must navigate to thrive in the cosmos. Lastly, consider this. Supernovae might have played a role in the evolution of life on Earth. Some theories suggest that the radiation from nearby supernovae could have influenced evolutionary changes by altering the Earth's climate or triggering genetic mutations. While the exact impact remains a subject of scientific inquiry, it is a fascinating reminder of the interconnectedness between cosmic events and life on our planet. As these thoughts gently dance in your mind, ponder the vastness of space and the intricate tapestry of life woven by the stars. Imagine wandering through the cosmos, where the brilliance of supernovae punctuates the vast expanse of space. Here's an astonishing fact. While many supernovae are incredibly bright, some are surprisingly dim, known as dark supernovae. These less luminous explosions challenge astronomers as they emit only faint traces of light, making them difficult to detect. The subtlety of these events opens up questions about how many might go unnoticed, hidden in the backdrop of the universe's grand theater. Speaking of the unseen, did you know that supernovae can leave behind pulsars, rapidly spinning neutron stars that emit beams of radiation? These cosmic lighthouses can rotate at incredible speeds, sometimes hundreds of times per second. Picture a star so compact and dense that it's just 20 kilometers in diameter, yet contains more mass than the Sun. It's a breathtaking phenomenon that pushes the boundaries of our understanding of matter. In a galaxy far away, a supernova might have an unexpected visitor. Sometimes the core of a massive star collapses into a black hole instead of a neutron star. But here's the twist. When the newly formed black hole begins to accrete matter, it can emit jets of high-energy gamma rays. These gamma ray bursts are among the most energetic events in the universe, briefly outshining entire galaxies. They are like cosmic fireworks with an intensity that's difficult to fathom. Let me share another wonder. Supernovae are not just celestial events, they are cosmic alchemists. The extreme conditions within these explosions can create elements heavier than iron, such as gold and uranium. It's a miraculous transformation where the raw materials of the universe are forged, enriching the cosmos with the building blocks for planets and life. Consider the vast distances supernovae can influence. It's mind-boggling to think that the effects of a single supernova can be felt hundreds of light years away. The shock waves can compress interstellar clouds, catalyzing the birth of new stars. It's a cosmic dance of destruction and creation, where the end of one star can herald the beginning of another. Here's a thought to ponder. Some supernovae are so powerful that they are classified as hypernovae, releasing 10 times more energy than typical supernovae. These colossal explosions can lead to the formation of black holes and are often associated with the mysterious gamma-ray bursts. The sheer scale of energy involved boggles the mind, highlighting the raw power inherent in the universe. And have you ever considered the role of supernova in cosmic recycling? When a star explodes, it spews out elements that eventually become part of new stars, planets, and even life. This process of matter being reused and reshaped is a testament to the universe's cyclical nature, where nothing is truly lost. Here's something that might surprise you. The light from a supernova can be observed centuries after the explosion occurred. Imagine peering into the sky and witnessing the remnants of an ancient stellar explosion, a silent testament to the passage of time in the cosmic scale. These echoes of light allow astronomers to study events that happened long before telescopes were invented. Have you ever wondered how supernovae are named? The naming convention is surprisingly straightforward, yet charmingly quaint. The first supernova of the year is labeled with an A, the second with a B, and so on. It's a reminder of humanity's endeavor to bring order to the vast and often chaotic universe. Speaking of order, did you know that supernovae are crucial for understanding the universe's expansion? By observing the light from distant Type Ia supernovae, scientists discovered that the universe's expansion is accelerating, leading to the theory of dark energy. This mysterious force makes up a significant portion of the universe, yet its nature remains one of the greatest puzzles in cosmology. It's fascinating to consider how supernovae can influence art and culture. Throughout history, the appearance of new bright stars in the sky has inspired myths and legends. In some cultures, supernovae were viewed as omens or celestial messages, illustrating the profound impact these cosmic events have had on human imagination. And here's a truly enchanting fact. Sometimes, supernovae can produce cosmic dust, those tiny particles that float through space. This dust becomes a crucial component in the formation of new planets, and can even drift into our solar system, becoming part of the very air we breathe. It's a magical connection between the cosmos and our everyday lives. Now, imagine this. The energy released by a supernova can be so intense that it compresses nearby gas and dust, potentially triggering the formation of entire star clusters. In this way, one star's violent end can spark the creation of 1,000 new stars, weaving a tapestry of light across the darkness of space. Finally, contemplate the idea that supernovae might affect the chemistry of entire galaxies. The elements scattered by these explosive events can enrich the galactic medium, altering the evolutionary path of galaxies over billions of years. This galactic alchemy reminds us of the profound interconnectedness of all cosmic phenomena, where even the smallest particles can influence the grandest structures. As you drift through these thoughts, let the wonder of supernovae and their far-reaching effects lull you into a peaceful contemplation, echoing the serenity of the universe itself. Let me share with you something intriguing about supernovae. These stellar explosions are not just limited to our Milky Way galaxy. In fact, they occur in every galaxy you can imagine, each one a cosmic spectacle in its own right. The universe is peppered with these brilliant displays, making them a universal phenomenon that connects galaxies light years apart. And did you know that astronomers use supernovae as cosmic rulers? By studying the brightness of certain types of supernovae, they can measure vast distances across the cosmos with remarkable precision. This technique has unveiled the scale of the universe, offering glimpses into its grand tapestry. Here's a curious thought. Supernovae can impact the very fabric of space-time. The immense energy released during these explosions generates gravitational waves, ripples in space-time that travel across the universe. Imagine these waves gently undulating through the cosmos, carrying with them the echoes of stellar cataclysms. Speaking of gravitational forces, did you know that the core collapse of a massive star can create one of the densest objects in the universe? Neutron stars born from supernovae are so dense that a teaspoon of their material would weigh billions of tons. It's astounding to think about the extremes of density and mass these remnants embody. Let me take you on a journey to the past. Some ancient civilizations may have witnessed supernovae without even realizing their cosmic origins. The remnants of these stellar explosions, known as supernova remnants, can linger in the sky for thousands of years. It's fascinating to consider how these celestial phenomena have been silently observed by our ancestors, influencing their understanding of the universe. Now, ponder this. Not all supernovae are created equal. There are different types, each with its own characteristics. For instance, Type Ia supernovae result from the explosion of a white dwarf in a binary system, while Type II supernovae arise when a massive star exhausts its nuclear fuel. This diversity adds richness to the tapestry of stellar explosions. Here's something that might surprise you. Supernovae can actually outshine entire galaxies for a brief moment. Imagine a single starburst so bright that it rivals the collective light of billions of stars. It's a reminder of the powerful forces at play in the universe, capable of producing such awe-inspiring brilliance. Speaking of brilliance, have you ever wondered about the colors of supernovae? The light from these explosions can display a spectacular array of colors determined by the elements ejected and the surrounding environment. This cosmic light show is a mesmerizing spectacle, painting the universe with vibrant hues. And here's a truly fascinating fact. Some supernovae are so powerful that they can strip nearby stars of their outer layers. Consider the sheer force required to peel away the outermost layers of a neighboring star, altering its evolution and composition. Such interactions highlight the interconnectedness of stars within their cosmic neighborhoods. Another surprising aspect of supernovae is their role in shaping the magnetic fields of galaxies. The shock waves produced by these explosions can amplify and reorganize magnetic fields, influencing the behavior of charged particles and affecting the dynamics of entire galaxies. It's a reminder of the unseen forces at work, weaving through the fabric of the cosmos. Imagine this. The shock wave from a supernova can travel at speeds of thousands of kilometers per second, sweeping through space and interacting with everything in its path. This rapid expansion can compress and heat interstellar gas, contributing to the complex processes of star formation and galactic evolution. And did you know that the dust and gas ejected by supernovae can eventually become part of new planetary systems? This cosmic recycling is a beautiful testament to the cyclical nature of the universe, where the remnants of one star can become the building blocks of countless others. Here's another captivating notion. Some supernovae can cause a phenomenon known as light echo, where light from the explosion reflects off surrounding dust clouds, creating ghostly apparitions in the sky. These echoes provide astronomers with valuable insights into the properties of the space surrounding the supernova, offering a glimpse into the dynamic interplay between stars and their environments. Consider, too, the role of supernova in the chemical evolution of the universe. By dispersing heavy elements into space, these explosions contribute to the enrichment of the interstellar medium, setting the stage for the formation of diverse planetary systems with complex compositions. And here's a thought-provoking idea. Supernovae can act as natural laboratories, allowing scientists to study extreme conditions that cannot be replicated on Earth. From high-energy physics to the behavior of matter under intense pressure, these stellar explosions provide a wealth of information that enhances our understanding of the fundamental laws of nature. Finally, imagine the impact of supernovae on the future of space exploration. As we venture further into the cosmos, the study of these explosive events will continue to reveal new mysteries, guiding our exploration and broadening our horizons. Allow yourself to be swept away by the grandeur of supernovae and the myriad ways they shape the universe. As the night deepens and the stars twinkle above, let the wonder of these explosive phenomena fill your dreams, carrying you on a journey through the cosmos as you drift into a peaceful slumber. Let me share something intriguing. In the aftermath of a supernova, the explosion can leave behind a pulsar, a rapidly spinning neutron star that emits beams of radiation like a cosmic lighthouse. These pulsars can rotate several times per second, creating a rhythmic signal that can be detected by telescopes on Earth. Can you imagine a star spinning so quickly that it completes a rotation faster than the blink of an eye? Such incredible speeds highlight the dynamism and energy of the universe. Here's another fascinating tidbit. Some supernova can be triggered by the collision of two stars. In particular, when two white dwarfs in a binary system merge, the resulting cataclysm can produce a supernova explosion. This interaction is a cosmic dance of sorts, where the gravitational pull brings them closer until they finally unite in a dramatic finale. It's a reminder of the intricate and sometimes violent interactions that occur in the vastness of space. Speaking of cosmic dances, did you know that supernovae can influence the orbits of nearby stars? The force of the explosion can act like a celestial billiard break, sending stars off on new trajectories. This reshuffling can alter the structure of star clusters and even affect the formation of new stars. It's like watching a cosmic game of musical chairs, where the players are constantly moving and changing positions. And here's a surprising notion. Supernovae play a crucial role in seeding the universe with elements necessary for life. The calcium in your bones and the iron in your blood were forged in the heart of stars and scattered across the cosmos by supernova explosions. These elements are essential for the development of planets and life as we know it, underscoring the deep connection between the cosmos and our own existence. Consider this. The energy released by a supernova can be so immense that it briefly surpasses the output of an entire galaxy. For a short time, the explosion outshines billions of stars, a beacon of cosmic energy that can be seen across vast distances. This extraordinary brightness is a testament to the powerful forces at play, capable of reshaping the universe on grand scales. Here's something you might find curious. The remnants of supernovae are not only visible through the light they emit, but also in other wavelengths, like radio and X-rays. These different forms of radiation provide astronomers with vital clues about the processes occurring within the remnants, offering a more complete picture of these stellar events. It's like tuning into different channels of cosmic storytelling, each revealing a unique aspect of the narrative. Speaking of cosmic storytelling, did you know that supernovae can create beautiful nebulae, glowing clouds of gas and dust that are often captured in stunning images by space telescopes? These nebulae, such as the famous Crab Nebula, are the remnants of past explosions, continuing to illuminate the night sky long after the initial event. Their ethereal beauty is a reminder of the transient yet impactful nature of stellar phenomena. Here's an enchanting thought. Some supernovae are so energetic that they can produce gamma-ray bursts, which are among the most luminous events in the universe. These bursts release enormous amounts of energy in a short period, often lasting just seconds or minutes. The origin and behavior of gamma-ray bursts remain one of the great mysteries of astrophysics, captivating scientists with their enigmatic brilliance. Have you ever wondered about the timing of supernovae? The exact moment when a star will explode is notoriously difficult to predict. Astronomers watch potential candidates, hoping to catch the precursor signs of an impending explosion. This unpredictability adds an element of cosmic suspense, as these stellar events can occur at any time, surprising both observers on Earth and those dreaming beneath the stars. And here's a delightful thought. The study of supernovae has even influenced art and culture. Throughout history, these celestial events have been recorded in various forms, from ancient rock carvings to modern-day literature and cinema, inspiring stories of creation, destruction, and renewal. These narratives remind us of the profound impact that the cosmos has on the human imagination, inspiring creativity and wonder. Did you know that the sound of a supernova, if it could be heard, would be incredibly loud due to the massive energy release? Of course, sound cannot travel through the vacuum of space, but it's fascinating to imagine the sheer cacophony that would accompany such an event. This thought invites us to consider the sensory experiences of the universe beyond just what we can see. Here's a heartwarming idea. Some supernovae have been observed in nearby galaxies, allowing astronomers to study them in extraordinary detail. These nearby events, still millions of light-years away, offer a rare opportunity to observe the intricacies of stellar explosions without the interference of distance. It's like having a front-row seat to one of the universe's most dramatic performances, offering rich insights into the nature of stars. Imagine this. The remnants of supernovae can create structures known as pulsar wind nebulae, where the powerful winds from a pulsar interact with the surrounding material. These winds generate complex and dynamic patterns, sometimes resembling ethereal spiderwebs stretching across space. The beauty and complexity of these structures highlight the intricate interactions that occur even after the explosive climax of a supernova. Finally, ponder this captivating aspect. Supernovae serve as cosmic timekeepers, helping astronomers to gauge the age of celestial objects and events. By studying the remnants and their expansion, scientists can piece together the timeline of the universe, unraveling its history one explosion at a time. This cosmic chronology not only deepens our understanding of the cosmos, but also connects us to the vast continuum of time, reminding us of our place in the universe's unfolding story. As you drift into slumber, let these tales of stellar explosions and cosmic wonder lull you into a deep, restful sleep, cradled by the universe's eternal embrace. Did you know that not all supernovae are created equal? There are two primary types, each with its own unique characteristics and origins. Type 1 supernovae occur in binary systems, where a white dwarf pulls material from its companion star, eventually leading to a catastrophic explosion. In contrast, Type 2 supernovae result from the collapse of massive stars that are at least 8 times the mass of our Sun. The diversity of these explosions reflects the varied life cycles of stars and the different paths they can take during their stellar journey. Here's a fascinating thought. Despite their destructive nature, supernovae play a crucial role in the birth of new stars. The shock waves generated by these explosions can compress nearby gas clouds, triggering the formation of new stars. This cycle of destruction and creation illustrates the dynamic and ever-changing nature of our universe. It's a poetic reminder of how beginnings and endings are intricately linked, even in the vastness of space. Speaking of new beginnings, did you know that some supernovae can lead to the formation of neutron stars or even black holes? When a massive star collapses, its core can become incredibly dense, forming a neutron star. If the core's mass is sufficient, it can continue to collapse into a black hole, a region of space where gravity is so strong that not even light can escape. These remnants are fascinating objects of study, offering insights into the extreme conditions that exist in our universe. And here's an intriguing idea. Certain types of supernovae can act as standard candles for measuring cosmic distances. Type E supernovae, for example, have a consistent brightness, which allows astronomers to calculate distances between galaxies with remarkable precision. This method has been pivotal in expanding our understanding of the universe's scale and has even contributed to the discovery that the universe is expanding at an accelerating rate. Imagine this. The shock wave of a supernova can travel at speeds of up to 30,000 kilometers per second. Such incredible velocity allows the shock wave to sweep through space, altering everything in its path. This rapid expansion spreads elements far and wide, enriching the interstellar medium and setting the stage for new cosmic events. The sheer power of these shock waves is a testament to the immense forces at work in the universe. Here's something you might find curious. Supernovae have been observed for thousands of years, with some ancient cultures recording these stellar events without ever understanding their true nature. Chinese astronomers were among the first to document a supernova in 1054 AD, which they described as a guest star that was visible in the daytime sky. This event created what we now know as the Crab Nebula, a beautiful remnant that continues to captivate observers to this day. Consider this. The elements produced in supernovae are not confined to their immediate surroundings. Over time, these materials become part of the cosmic tapestry, traveling vast distances across the universe. This process of enrichment and mixing ensures that the building blocks of life are distributed throughout the cosmos, laying the groundwork for future generations of stars and planets. Did you know that some supernovae are so rare that they occur only once in a century for a given galaxy? These rare cosmic events are eagerly anticipated by astronomers, who hope to capture them with powerful telescopes and gain new insights into the life cycles of stars. The rarity and unpredictability of these explosions add an element of excitement and wonder to the study of the cosmos. Here's a delightful notion. Some supernova remnants emit jets of particles that travel at nearly the speed of light. These jets, often associated with neutron stars and pulsars, can extend thousands of light years across space, creating spectacular displays of energy and motion. The study of these jets offers a window into the extreme environments surrounding these exotic objects, deepening our understanding of cosmic dynamics. And speaking of cosmic wonders, did you know that supernovae can influence the magnetic fields of galaxies? The shocks and turbulence generated by these explosions can amplify and reorder magnetic fields, affecting the behavior of charged particles throughout the galaxy. This interaction between supernovae and magnetism provides crucial insights into the complex interplay between different cosmic forces. Here's an enchanting idea. In addition to their scientific importance, supernovae have inspired countless works of art and poetry. The dramatic imagery and profound themes of birth, death, and rebirth resonate deeply with the human experience, bridging the gap between the cosmos and our inner worlds. Artists and writers have long drawn inspiration from these celestial events, enriching our cultural heritage with their interpretations of the universe's grandeur. Imagine the wonder of witnessing a supernova from afar, a distant yet brilliant event unfolding light years away. These stellar explosions connect us to the universe in profound ways, reminding us of the interconnectedness of all things. As you reflect on these cosmic marvels, let the stories of stars and supernovae fill your dreams with a sense of awe and wonder, carrying you gently into the night. Imagine the night sky as a vast canvas, with supernovae painting it with the most brilliant strokes of light. Did you know that the energy released by a single supernova can outshine an entire galaxy for a brief period? This magnificent burst of energy is a dazzling reminder of the raw power that stars possess. As you think about this, consider that the light from a supernova can travel millions of years before reaching us, a fact that connects us across time and space to events that occurred long before humans ever walked the Earth. Here's something quite astonishing. Some supernovae are triggered by the merging of binary star systems, a cosmic dance that ends in a spectacular finale. When two stars orbit closely, they can eventually spiral inwards, colliding and unleashing a colossal explosion. This celestial ballet, resulting in a supernova, is a testament to the intricate dynamics that govern stellar systems. Speaking of stellar surprises, have you ever wondered what happens to the planets that orbit a star that goes supernova? The sudden increase in brightness and the ejection of stellar material can devastate nearby planets, stripping away atmospheres and altering their orbits. Yet, this cosmic disruption can also lead to the creation of new planetary systems in the aftermath, a cycle of destruction and creation that echoes throughout the galaxy. In the realm of science fiction, we often hear about the dangerous radiation from supernovae. Here's a real-life fact. Earth is occasionally hit by cosmic rays from distant supernovae. These high-energy particles can reach our planet, contributing to the natural background radiation we're exposed to. Though they pose no significant risk, it's fascinating to think of how these ancient explosions still impact us from across the cosmos. Another captivating aspect of supernovae is their role in cosmic recycling. When a star explodes, it scatters elements like carbon, oxygen, and iron into space, enriching the interstellar medium. These elements are crucial for the formation of new stars and planets, and ultimately for life itself. Can you imagine that the iron in your blood was once forged in the heart of a long-dead star? This thought illustrates the profound connections between us and the cosmos. Here's a tidbit that might surprise you. Not all supernovae result from massive star deaths. Some occur in binary systems, where a white dwarf star accretes material from its companion. When the white dwarf reaches a critical mass, it undergoes a thermonuclear explosion, a Type 1a supernova. This process is quite different from the core collapse supernovae of massive stars, showcasing the diverse ways in which these powerful events can unfold. Did you know that the remnants of supernovae can continue to emit light for thousands of years? The expanding shell of gas and dust can remain visible, glowing brightly in different wavelengths of light. These supernova remnants, such as the Crab Nebula, serve as lasting beacons of the incredible events that created them. They provide astronomers with rich opportunities to study the aftermath of stellar explosions and the complex processes that follow. Consider the impact of supernovae on their galactic environments. When a supernova explodes, it sends shock waves through the surrounding space, compressing gas and dust and triggering the formation of new stars. This catalytic effect highlights the interconnectedness of cosmic events, where the death of one star can sow the seeds for the birth of others, perpetuating the cycle of stellar life. Here's an intriguing concept. Supernovae can inform us about the chemical evolution of galaxies. By studying the elements produced in these explosions, astronomers can trace the history of chemical enrichment in the universe. This knowledge helps us understand how galaxies evolve over time and how the elements crucial for life have spread across the cosmos. Imagine the surprise of ancient astronomers witnessing a supernova without the tools to comprehend its nature. These mysterious guest stars sparked awe and curiosity, leading to records and interpretations that still captivate our imagination today. It's a humbling thought that our ancestors gazed at the same sky, pondering the same cosmic wonders that inspire us now. Speaking of inspiration, supernovae have also influenced technological advancements. The study of these events has driven the development of sophisticated telescopes and instruments, enabling us to peer deeper into the universe. The pursuit of understanding supernovae has thus not only expanded our cosmic knowledge, but also propelled technological progress, benefiting various fields of research. Did you know that supernovae can create cosmic dust? The shock waves from these explosions condense gas and dust into tiny solid particles that drift through space. This dust is a crucial component in the formation of planets and stars, highlighting the role of supernovae in shaping our universe's structure. And here's a remarkable fact to ponder. Some supernovae might have played a role in mass extinction events on Earth. The radiation from a nearby supernova could potentially affect our planet's atmosphere, altering climate conditions and impacting life. While this remains a topic of scientific investigation, it's a thought-provoking example of how interconnected we are with cosmic events. Finally, as you drift into slumber, let this idea linger. In the grand scheme of the universe, supernovae are both endings and beginnings, marking the final chapter in a star's life while setting the stage for new stories. Their light, though momentary, leaves an indelible mark on the cosmos, echoing the eternal dance of creation and transformation. May these tales of stellar explosions fill your dreams with wonder as you journey through the vast, star-studded expanse of your imagination. Let me share something intriguing about supernovae that might surprise you. While we often think of these stellar explosions as fiery spectacles, they can actually be quite symmetrical. In many cases, despite their chaotic nature, supernovae can explode in remarkably regular, nearly spherical patterns. This symmetry provides important clues to astronomers about the physical processes governing the explosion's dynamics. Moving on to another remarkable fact, did you know that supernovae can outshine entire galaxies? For a brief period, the light from a single exploding star can surpass the combined luminosity of the hundreds of billions of stars in its host galaxy. Imagine the sheer energy required to produce such an event. It's a mind-boggling reminder of the power contained within the cosmos. Here's something you might find interesting. Supernovae are classified into different types based on their spectra and the physical mechanisms behind them. One lesser-known type is the type Ib and Ic supernovae, which are believed to result from the core collapse of massive stars that have lost their outer hydrogen layers, either through stellar winds or a companion star. These types add even more diversity to the stellar explosions we observe. Speaking of variety, another surprising aspect involves hypernovae. These are exceptionally energetic supernovae, sometimes associated with gamma-ray bursts. The energy output of a hypernova can be up to 10 times greater than that of a typical supernova, making them some of the most powerful events in the universe. Hypernovae provide vital insights into the extreme ends of stellar evolution. As we delve deeper into the intricacies of these cosmic phenomena, consider this. Supernovae are essential for creating neutron stars and black holes. When the core of a massive star collapses, it can form an incredibly dense neutron star, or, if the core is sufficiently massive, these remnants continue to captivate scientists, offering a glimpse into the most extreme states of matter and gravity. Here's something that might catch you by surprise. Our own Milky Way galaxy is home to a recent supernova remnant, known as Cassiopeia A. Although the supernova itself took place over 300 years ago, its remnants remain a vital research subject, allowing astronomers to study the aftermath of such explosions in our galactic backyard. Another fascinating detail is the role of supernovae in the distribution of cosmic rays. The shock waves generated by these explosions can accelerate particles to near-light speeds, creating cosmic rays that travel through the galaxy. These high-energy particles play a role in shaping the interstellar medium and even influence the conditions in distant planetary systems. Continuing this exploration of interconnectedness, it's intriguing to note that supernovae can have an impact on star formation. The shock waves from a supernova can compress nearby gas clouds, initiating the process of starbirth. This means that the death of one star can trigger the birth of many new stars, illustrating the cyclical nature of the cosmos. Now, let's journey back to Earth for a moment. It's thought-provoking to consider that some isotopes found in the ocean floor might originate from supernovae. Researchers have detected iron-60, an isotope produced in supernovae within ancient ocean sediments. This discovery suggests that our planet has been dusted with material from these distant stellar explosions, linking us to cosmic events across time and space. Have you ever wondered about the sheer distance over which supernovae can affect their surroundings? The shock waves from a supernova can travel hundreds of light years, influencing vast regions of interstellar space. This immense reach underscores the profound influence these events have on the structure and evolution of galaxies. Here's a delightful tidbit about the study of supernovae. Astronomers often rely on light echoes to learn more about past explosions. When a supernova occurs, light from the explosion can reflect off surrounding dust clouds, reaching Earth long after the initial event. By studying these echoes, scientists can piece together the details of supernovae that happened hundreds of years ago. Imagine the possibilities as we consider the future of supernova research. With advancing technology, astronomers are developing new ways to detect and analyze these explosions. Upcoming missions and telescopes promise to uncover even more about the life cycles of stars, enhancing our understanding of the universe. And here's a curious fact to wrap up this exploration. Supernovae have inspired myths and legends across cultures throughout history. From the Chinese astronomers who recorded the guest star of 1054, now known as the Crab Nebula, to the stories of deities and omens, these stellar events have left a deep imprint on human imagination. As we gently draw this cosmic journey to a close, let's appreciate the profound impact that supernovae have on the universe. They are not just celestial fireworks, but essential processes that shape galaxies, create elements, and inspire wonder. As you drift off to sleep, let your thoughts wander through the starry skies, where the echoes of stellar explosions tell tales of creation, destruction, and endless possibility. May these musings accompany you into the realm of dreams where the universe's mysteries unfold in quiet reverie.